Well, in many different ways, because FLUIDOS allows devices in the continuum to share all sorts of resources among them. And this opens up unprecedented possibilities in terms of sustainability. I can think of, for instance, hardware. So we can decide which hardware is the most efficient where to execute a specific workload. Or if we think of the geographically distributed edge nodes that we have, we can move the workload in space, or geographically better, towards those devices which are powered by renewable sources rather than choosing devices that are powered by fossil fuel. This all adds to what's called the OPEX, so everything related to the operation of devices, but we can also reason in terms of CAPEX. So if we consider how the devices are produced, and specifically what is the carbon footprint related to the production of the devices, well, we can actually combine both OPEX and CAPEX to obtain some more enhanced allocation, sustainable allocation. Two FLUIDOS nodes within a continuum can communicate through a protocol that we designed within the FLUIDOS project, which is called RIA. RIA allows nodes in the continuum to exchange information on the type of resources that are advertising in the continuum. So for instance, Kubernetes, slice of Kubernetes cluster, virtual machines, and so on. And they can also add information related to the energy efficiency of the resources that is being advertised. In such a way, the consumer, so who is purchasing those resources, is aware on how much sustainable that specific resource is. Within a FLUIDOS infrastructure, there is a lot of possibility when it comes to sustainability for the execution of the application. And from a preliminary evaluation that we performed, that we realized that by just understanding what is the optimal load for a specific device, we can actually minimize the power consumption while maintaining the same quality of service for the execution of the application. And we estimated that to be around 15%. So by just understanding what is the correlation between the performance of a given machine and the energy consumption that is required to execute those workloads, we can actually understand which is the best way to consolidate workload onto those devices. Then, on top of that, we can also implement enhanced allocation policies that takes into consideration the type of energy that is used to power those devices.